Hi you guys, this is Miss Pruitt and I wanted to do a video with you guys about implicit differentiation. So let's get started. Jumping right into this. Implicit differentiation requires for us to do 4 steps. First step, differentiate both sides with respect to x. Second step, you're going to put all of your dy dx terms on one side of the equal sign and all the other terms on the other side. Step 3, factor out dy dx. And step 4, solve for dy dx. Okay, so let's take the derivative of this first thing. I'm going to take the derivative implicitly because it's not set explicitly where it's just y equals. It's not easy peasy. So what I'm going to do is take d dx of the entire equation, which is y to the 4th power x cubed, y to the 5th, minus 2x to the 7th equals 13. Alright, so of course, my next step is to distribute the ddx to each and every term on both sides of the equal sign. So that means I'm going to do ddx y to the 4th. I'm also going to take ddx of x cubed y to the 5th. There's different ways to write this, but in class we have been writing that we're going to take ddx of negative 2x to the 7th power equals ddx of 13. So let's do this one by one. If I'm taking the derivative of y to the 4th power in terms of x, well, this equation is not in terms of x. It's just y. It's some function y that we don't know. So we're going to have to treat this as a function within another function. So which means I'm going to have to do chain rule in this case, with my outer function being 4, my inner function being y. So doing chain rule, I would do 4 times y cubed times the derivative of the inside, y. Well, the derivative of y is dy dx. Plus, now I have to do it over here, and I'm going to take derivative of that function times the derivative of the next function. Well, if I'm multiplying two functions, it has to be product rule. So that means I'm going to take the first and multiply it by the derivative of the second. Well, it's y to the 5th power, just like the y to the 4th. I'm going to have to do chain rule. So this is 5y to the 4th power times the derivative of the inside, which is dy dx. But I'm not done. It's the first times derivative of the second plus the second times the derivative of the first, which would be 3x squared. And moving on to the next term, the derivative of negative 2x to the 7th power. Well, thank goodness that is in terms of x. So the derivative would be negative 14x to the 6th power. And on the other side of the equal sign, the derivative of 13 is 0. All right. So we've taken the derivative on both sides. And so now I want to make sure that I have everything that has dy dx on one side of the equal sign and everything else on the other side of the equal sign. So I'm going to keep 4y cubed dy dx. I'm also going to keep, I'm just going to combine these. This would be 5x cubed y to the 4th dy dx. And I'm going to subtract this term and add this term to both sides. So I want to move them over to the other side of the equal sign. That will give me 14x to the 6th power minus 3x squared y to the 5th. Okay, continuing on because I needed more room. I'm going to do the next step. The next step is to factor out the dy dx. So I'm going to pull out or factor out dy dx. And then I'm going to write in what I would have left. I would have 4y cubed plus 5x cubed y to the 4th power equals 14x to the 6th power minus 3x squared y to the 5th power. And of course, our whole goal is to get dy dx by itself. Y to the 4th. So I'm going to divide both sides by everything else that's on the left-hand side. X cubed y to the 4th. And I know because all that cancels out. And even though it looks a little funky, that will be your final answer. All right, you guys, moving on to another example. Find the line of tangency and normal line to the curve x squared minus xy plus y squared equals 7 at the point negative 1, 2. We talked about this in class, of course. How do you find a line of tangency? Derivative. And what does normal line or what does normal mean? It means the slope that's perpendicular. It means perpendicular to. So if I'm given one slope, it's perpendicular or it's normal to that slope. It's going to be negative reciprocal. All right, so let's go ahead and continue on with the example number 2. Find the line of tangency. Well, we're going to have to take the derivative. It is not written explicitly. We're going to have to do implicit differentiation. So I guess I'm just going to skip the step of the ddx of the entire function. Realize that we're going to just be taking the derivative of all of these individually. So the derivative of x squared is going to be 2x. Taking the derivative of the next term, well, it's going to be like a function times another function. So I need to do product rule. It will be the first times the derivative of the second plus the second times the derivative of the first, which is just 1. You don't really have to write that. All right, moving on. The next term, I didn't mean to cross it out. The next term, y squared. Well, that is like a function within a function. It is the function y that's inside of a power function. So I'm going to have to do chain rule. So using chain rule, that will be 2 times y times dy dx, because derivative of y, because of chain rule, is dy dx. And it's all going to equal the derivative of 7, which is 0. So, of course, let's go ahead and clean this up. This is 2x minus x dy dx minus y plus 2y dy dx equals 0. Well, I want to get all of my dy dx terms on the left and all of my other terms on the right. So that means I'm going to have negative x dy dx plus 2y dy dx. And I'm going to set it equal to, I'm going to subtract 2x from this side, and I'm also going to subtract, excuse me, I underlined the wrong thing. I'm going to add y to both sides. That's how I'm going to move everything over. So that's going to give me y minus 2x on the right-hand side. My next step, of course, I want to factor out this dy dx. I factor out dy dx. That would leave me with negative x plus 2y equals y minus 2x. Okay, I'm just rewriting this so that I can have a little bit more room to finish. All right, so again, I'm going to get this dy dx by itself, so I'm going to divide both sides by this to get rid of it. So I know that the derivative is going to be y minus 2x divided by, and I'm just going to switch these two, their positions to make it look a little bit more neat. I don't want to start any of my terms with a negative. So yay, we have found the derivative. However, that is not what the question is asking us for. It wants us to find the equation of the line of tangency and the normal line. So the only thing that we have found is our tool in order to find the slope. Well, it's given us this point for a reason. It's telling us to use that as our x value and y value. So I'm going to plug that in over here. I'm going to plug in 2 for y and negative 1 for x. So this is going to give me 2 minus 2 times negative 1 over 2 times 2 minus negative 1. So if you do your little arithmetic, you would get 4 over 5 is the slope. Using point slope form, that means that my equation will be y minus y1, which is 2, equals my slope times x minus x1. Well, minus a negative 1 would mean plus. So that's one of my answers. That is the line of tangency. But it also wants me to find the normal line. The normal line will be perpendicular. So its slope would be the negative reciprocal. So it's still generally the same equation. The only difference is going to be the slope. So the negative reciprocal of 4 over 5 is negative 5 over 4. X plus 1. And now I have solved for number 2.